good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are going to be thunderstruck. Thunder by algebraic expansion and factorization. I'm thrilled. Let's get to it, shall we? All right, we'll come back to some thunderstruck towards the end of the video. Okay, so expand and simplify, and all I'm going to do is tell you that, or remind you, the rules of exponents. A to the m times a to the n is equal to the a to the m plus n. So this is not too horrible. This becomes x to the negative 1/2 plus 3/2, right? If I distribute this term, plus x to the negative 1/2 times 2x to the 1/2 plus x to the negative 1/2 times negative 3x to the negative 1/2. And all of these have the same base, so I just add the exponents. Negative 1 plus 3/2 is x to the 2/2 plus 2 x to the negative 1/2 times x to the 1/2 is x to the 0 power minus 3 x to the negative 1/2 times x to the negative 1/2 is x to the negative 1. So this becomes x to the first plus 2 times 1 is 2. I don't need that first there. Minus 3 over x. Okay, next, simplify. Well, we are going to expand this. So this becomes 2 to the x times 2 to the x plus 2 to the x times 1 plus 3 times 2 to the x plus 3 times 1. Now be careful. You cannot take the multiply 2 times 2 here because our order of operations say that exponents must come before multiplication. And I can't do anything with these x. I can't evaluate the exponents because I don't know their values. They're just in terms of x. But I can use my rule of adding the exponents of the product of two bases. So this becomes 2 to the x plus x, or 2 to the 2x. Here I have 1 to the x, and here I have 3 more. 1 plus 3 is 4 times 2 to the 2x plus 3. And this is a perfectly good answer, but you need to be able to manipulate these in different ways depending on your need in the future for future more difficult problems. For example, I could write this as 2 to the x squared, because 2 to the x squared, I would multiply the exponents. X times 2 is 2x, plus 4 times 2 to the 2x plus 3. I could also rewrite this 2 to the x. I'll keep 2 to the x squared. I could go back to this, doesn't matter. Well, 4 I can write as 2 squared. And if it's 2 squared, then I have the same base, 2 squared times 2 to the x. Why do I have 2x here? This is just 2 to the x. Uh-oh. Mrs. Becker telling me the wrong thing. So this would be 2 to the 2 plus the x, or x plus 2 plus 3. I could even write this as, instead of 2 to the x squared, I could have written it as 2 squared to the x power, right? Well, 2 squared is 4. So I could write this as 4 to the x power plus 4 times 2 to the x plus 3. Any combination of those. It just is a matter of what we want to do with it as far as which form we want. This one right here is going to be very helpful to us. You'll see that a little bit later. Part B, 7 to the x plus 7 to the negative x squared. This is of the form a plus b squared is equal to a squared, or no, this is of the form a plus b squared, which we should know is equal to a squared plus 2ab plus b squared. And we can do it like that, or we can just realize that it's like this. Okay, so we will just expand as usual. 7 to the x times 7 to the x plus 7 to the x times 7 to the negative x plus 7 to the negative x times 7 to the x plus 7 to the negative x times 7 to the negative x. All of these have the same basis, so this is 7 to the 2x. X plus x is 2x. 7 to the x minus x is 7 to the 0. 7 to the 0 again right here. Plus 7 to the negative 2x, which is equal to 7 to the 2x plus 2. 1 plus 1 here. Anything to the 0 power is 1. Plus 1 over 7 to the 2x. And there's a lot of different ways we could write this. And you need to be able to do that. But I will just leave it as that for now. Okay, let's do some more. Factorize. All right. Lots of different things happening here. So it might be easier if you realize that 2 to the n plus 3 is really 2 to the n multiplied by 2 cubed plus 2 to the n. Now when factorizing, if it's not a quadratic or in the form of a quadratic, I'm just looking to factor something out from each term. I'm looking for something they have in common. And in this case, you can see they have 2 to the n in common. So I factor out 2 to the n. Oops, I got ahead of myself, and I'm left with 2 cubed plus 1. And then, of course, 2 cubed is 8. And then I can write that as 9 times 2 to the nth power. For part B, similar. I can write this as 2 to the n times 2 cubed. And the reason I'm writing that as 2 cubed is I can write 8 as 2 cubed, and I have two terms that have 2 cubed in common. And so then we have 8 times 2 to the n plus 1. And then finally here, I have 2 to the 2n in common. So I can write this as 2 to the n plus 1 because 2 to the 2n times 2 to the n, you would add 2n plus n to get the 3n. And then 2 to the 2n times 1 obviously is going to give us 2 to the 2n. Okay, now here we go back to our rules of factoring. Some forms of factoring, I see a minus, I have two terms. That is going to be, once we manipulate it, it's going to be in this form, a squared minus b squared, which factors into a plus b times a minus b. But 4 to the x minus 9, I know 9 is a perfect square, 4 is a perfect square. So can't I write 4 to the x as 2 to the x squared? Because 4 is 2 squared. So if I think of 4 to the x as 2 squared to the x, that's 2 to the 2x, which is also equal to 2 to the x squared, minus 3 squared. And this is my a minus my b, each of them squared. So that's in the form of a plus b times a minus b. Okay, and there you go. We have it factored. And if this were equal to 0, this is quite nice, because then I can use ZPP, you know me, the zero product principle, to solve this. Part B looks a little intimidating, okay? But take a look at this. I've got a 3 to the x power here. 9 to the x, I can write as 3, I can write 9 as 3 squared to the x power plus 4 times 3 to the x plus 4. And I'm doing this a little bit more step by step. I could also write this as 3 to the 2x or 3 to the x squared plus 4 times 3 to the x plus 4. Now, I have a term here, my term, or you can think of your variable as 3 to the x, and I would just factor this into the product of two binomials. One way to see that more clearly is say, oh, okay, let n, or your favorite variable, equal 3 to the x, and then rewrite this. So then we would have n squared, replacing 3 to the x with n, plus 4n plus 4, Well, that's equal to n plus 2 times n plus 2, which is n plus 2 squared, which is replacing 3 to the x back in 3 to the x plus 2 squared. Or you could go right from here and say, oh, that's going to be 3 to the x plus 2 times 3 to the x plus 2, which is equal to 3 to the x plus 2, the quantity squared. Okay, a couple more. How do I do this? All right, well, 6 to the n over 3 to the n. Got to remember my rules of exponents. And I'm hoping to cancel something out here, and then I can remember, oh, I can write 6 as 2 times 3 to the n power over 3 to the n power. Well, this can be written as 2 to the n times 3 to the n, because everything within a parentheses is raised to a power, over 3 to the n. The 3 to the n's go away, and I'm left with 2 to the n. Bam! And then part B, same idea. 4 to the n I can think of as 2 times 2 to the n power. And 6 to the n I can think of as 2 times 3 to the n power. And you might see this already. Well, that's 2 to the n times 2 to the n over 2 to the n times 3 to the n. This goes away. Same thing over the same thing is equal to 1. So I'm left with 2 to the n over 3 to the n, which is equivalent to 2/3 to the n power. Okay. And let's see, one more example, I think. All right. So again, we got a fraction here, got a sum up here and a denominator. So for part A, I'm going to think of that as 3 to the n over 3 to the n plus 6 to the n over 3 to the n. So that's going to be 1 plus, we just did 6 to the n before over 3 to the n. I'll do it again. So that's 2 times 3 to the n over 3 to the n, which is 1 plus 2 to the n times 3 to the n over 3 to the n. The 3 to the n's get the kapow, they go away, and I'm left with 1 plus 2 to the n power. For B, same idea. I'm going to kind of rewrite as I go, though. I'm going to rewrite 2 to the m plus 2 as 2 to the m times 2 squared over 2 to the m minus 2 to the m over 2 to the m. Bam, the 2 to the m's go away. I'm left with 2 squared, which is 4. 2 to the m over 2 to the m is 1, and this is equal to 3. And finally, I'm going to rewrite this as 2 to the m times 2 cubed plus 2 to the m over 9. And then I will have 2 to the m in common here. And I have 2 to the m times 2 cubed plus 1, because they have 2 to the m in common, over 9. Look what's going to happen. 2 to the m times 2 cubed plus 1 is 8 plus 1 is 9, over 9. Kapow, the 9's cancel, and I'm left with 2 to the n. All right, so we are looking at this, and well, I should say the reason we're looking at it is we have to be able to quickly manipulate exponents so we can solve more difficult problems. And with that, I am going to sign off here. A little bit more Thunderstruck. I know how we love it. And I shall say that I am... Oh!